Now, here's an interesting question. Can we find formulas for cosine 3 theta and cosine 4 theta in terms of cosine theta? And of course, this could also be done for sine 3 theta and sine of 4 theta in terms of sine of theta. But we'll just do these two, and I'll leave the other sine of 3 theta and sine of 4 theta as an exercise. First, looking at cosine of 3 theta. Of course, that's cosine of 2 theta plus theta, so we're going back to the same technique we used to derive the formula for cosine of 2 theta as cosine of theta plus theta. So it's the same idea at the start. And so that would be cosine, cosine, secant, sine, sine. Cosine 2 theta, cosine theta, minus sine 2 theta, sine theta. That's easy enough. And we'll replace this cosine, since we're trying to get it in terms of cosine theta, we'll replace this cosine 2 theta with 2 cosine squared theta minus 1. That would be the choice there. This sine 2 theta, we'll just have to replace it with 2 sine theta cosine theta as we normally would. And now notice when we multiply out this side, we get 2 cosine cubed theta minus cosine theta. Here we have 2 sine squared theta times cosine theta, and this 2 sine squared theta can now be replaced with 2 times 1 minus cosine squared theta. Remember, our goal is to have everything in terms of cosine theta. And so multiplying this all out, this is negative 2 times 1 times cosine theta, so that's negative 2 times cosine theta, along with this negative 1 cosine theta gives us negative 3 cosine theta. We have 2 cosine cubed theta here. We have minus 2 times negative cosine cubed theta, because this cosine squared times this cosine, so that winds up being plus 2 cosine cubed theta, so it gives us a total of 4 cosine cubed theta. And here is the formula just as we stated. The formula for cosine 3 theta in terms of cosine theta. We got 4 cosine cubed theta minus 3 cosine theta. The one for sine 3 theta is similar, but not the same. Or what about cosine of 4 theta? Could we find something for that? And the answer is sure. Do the same thing. Make it cosine 2 theta plus cosine 2 theta, which is cosine squared 2 theta minus sine squared of 2 theta. And we're going to replace this cosine squared of 2 theta with 2 cosine squared, cosine of 2 theta. We're going to replace that with 2 cosine squared theta minus 1. Replace this one also with 2 cosine squared theta minus 1. And we're going to change this one to, just this much, there it is, to 2 sine theta cosine theta, and then this one as well, so we'll have 2 sine theta cosine theta, that quantity squared. So what's the result of all that? Well, this would multiply out 4 cosine to the 4th theta minus 4 cosine squared theta plus 1, you should know how to do that. Multiplying polynomial times a polynomial should be easy. And then this part may be a little bit more of a challenge, but I don't think it should be too bad. We get 4 from squaring the 2. We get cosine squared from squaring the cosine. And instead of writing sine squared, I went ahead and changed it to 1 minus cosine squared, because remember, our goal is everything in terms of cosine theta. So here's everything in terms of cosine theta, and the rest is just an algebraic simplification. We have to take all this and add it to this, and if you can look carefully, you'll see we got 4 cosine to the 4th theta, and here this negative times this negative would give us positive 4 cosine to the 4th theta as well, so that's 8 cosine to the 4th theta. Here we have a negative 4 cosine squared theta, and this times this 1, you can see, would also give us another negative 4 cosine squared theta, so that would give us a total of negative 8 cosine squared theta, and finally plus this 1. And that's the formula we were seeking for cosine of 4 theta in terms of cosine of theta. There are also half-angle formulas that can easily be derived from our double-angle formulas. Just one slight transformation. And of course, it's easy to get the formula for tangent of alpha over 2 from sine of alpha over 2 over cosine of alpha over 2. I think you could probably see that one pretty quickly. So let's derive one of these. Let's derive the formula for cosine of alpha over 2. And here is our example. Show that cosine of alpha over 2 is plus or minus square root of 1 plus cosine alpha over 2. And we're going to start with the double angle formula for cosine. And we're going to solve it for cosine squared theta first. And of course that means we'd add 1 to both sides. I move this over here, divide both sides by 2. And then take the square root of both sides. So cosine theta is plus or minus square root of 1 plus cosine 2 theta over 2. However, that's not the formula we were looking for. We want it to look like this. But it's an easy transformation. Just replace theta with alpha over 2. And we have cosine of alpha over 2 instead of theta equals 1 plus cosine of 2 times alpha over 2 divided by 2. But 2 times alpha over 2 is just alpha. So there we have the formula we were trying to derive.